Hello guys, this is Aim and welcome to the channel. If you are a computer science student, you might understand how hard it is to devise an algorithm. But a good optimized algorithm can always be appreciated. But why are we talking about algorithms today? Learning algorithms and implementing them are very obsolete and unnecessary for real life programming, right? Is it? One never know where old but good algorithm might come into handy. In this video, we're gonna discuss about an 280-year-old algorithm which was implemented and used in one of the Google's application, Google Trips. If you do not know what is Google Trips, it is an application where we can plan our vacation. One of the feature of it is pre-plan the places you are interested in visiting, and Google then plans a minimum route where we can visit all the places in minimum travel time as possible. So any problem related to maps and these cities brings us to the concept of graph theory. The problem statement is very similar to that of traveling salesman problem. If you are a computer science student, you will be knowing about traveling salesman problem. It states that given a list of cities and distances between the pair of cities, what is the shortest possible route which visits all the cities exactly once and returns back to the origin city. But traveling salesman problem is a NP hard problem. That means it cannot be practically implemented until you make some assumptions. In 1736, Leonard Euler has studied about the following problem. He stated that is it possible to cross each bridge of a city exactly once? But as it turns out, for the city of Königsberg, no matter what, Königsberg, the answer is no. So later Euler discovered that any graph with nodes of having even number of edges can form a cycle, and this kind of a graph is called a Euler's graph. So then and only then it is possible to have a route which crosses each edge exactly once. Keep this in mind because we will rely on this in later. Now coming to the assumptions to be made for traveling salesman problem. One such assumption is triangle inequality. What is triangle inequality in the first place? Triangle inequality states that for this particular triangle, going in the straight line A to B is much shorter than detouring from A to C and then to B. So in short, adding an extra place to visit never makes the route shorter. So having this geometry at underlying, we can actually use an algorithm which made as an assumption upon triangle inequality, and fortunately in real life triangle inequality holds true. So triangle salesman problem can be approximately solved by another algorithm which was discovered by Christopher Diss in 1976. He gave an elegant proof which makes sure that the path that is found is always very closer to that of the optimal solution. So this is very important part of the solution, and this has built upon the Euler's paper. If you want to know more in detail about the algorithm and how these both concepts are combined together detailed, there's a blog post linked in the description below, and so this is how a huge problem, in fact NP hard problem, is cleverly solved by combining concepts of couple of algorithms and their discoveries. I hope this motivates you to learn more about algorithms and dig deeper and apply to real world problems. If you like this video, another great algorithm was discussed in one of the previous Tech Talks video, that is consistent hashing. You might as well like that. If you haven't checked that video, check that out too, and I'll see you in the next one.